Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of functions, specifically how we can evaluate an element in their domain, and we'll do it in 5 minutes or less. So we have a basic function here, right? And before we even get into how we evaluate functions, let's make sure we understand and agree with what a function is. Now, this is something we've been looking at for a few years, not just Algebra 1. We started looking at it in 8th grade really closely. So a function is a mathematical relationship where every input leads to just one output. And when we're talking about inputs and outputs, right, we're talking about our independent variables. And then we're talking about our dependent variables. And typically our independent variables are going to be your x's, and your outputs are going to be your dependent variables. And those are typically going to be your y's, or we think of them as our x's and our y's. This is what we call function notation, which means that this is going to be a function simply because it's in this notation of f of x. Now, it's easy for us to think, oh, the f stands for function. If that's how we want to remember it, that's fine, but actually f is the name of the function. So this is function f. Because think about it, sometimes we don't see f of x, sometimes we'll see h of x, or we'll see g of x, right? So that's just the name of the function. And this x here lets us know, all right, if we want to evaluate part of that function, we can put that in there, because as a function, right, we know that if we were to graph it, we would get this something. Let's say we're doing a quadratic, we got a parabola here. We would do what we call the vertical line test to test whether or not it's a function. And if you draw a vertical line, it should only hit the actual function once. If it hits it more than once, it's not a function, because each x leads to just one y. There's no way you can have one x value and two different y values. But this function notation right here is different than, we could replace it with y equals 3 x squared minus 7 squared. See the difference here, even though they both for the most part kind of serve the same purpose, this function notation, which is what we have, lets us know this is a function, which means it is going to have every input leading to just one output. It is going to pass the vertical line test. It's going to have domain. It's going to have a range that we can define, all of that. Whereas when we're looking at just this y notation, maybe it is a function, maybe it's not. So how do we evaluate it? Well, all we do is we say, let's pluck out one value from our domain. So let's say x equals -2. Okay, so how would we write that? Well, what we do is we would, and I'll write that right here, we would say f of, instead of f of x, f of -2. So that lets us know, all right, we're going to evaluate that -2. And we're just going to put that right there where that x is. But that f of -2 lets us know that we're going to do substitution. Right? Then we're going to use our order of operations, PEMDAS, please excuse my dear Aunt Sally. Right? So we're going to make sure we do our parentheses first, exponent second. Multiplication and division are inverse operations, so they can go in either order. Same with addition and subtraction. So within this parentheses, right, we need to make sure we handle that exponent first. So we'll say f of -2 equals 3. I'm going to just simplify that to 4 minus 7 squared. All right, so now we need to take care, within that parentheses, that subtraction. F of -2 equals 3, and that's going to end up being -3 squared. Now we can finally get to that exponent. So f of -2 is going to be 3 times -3 squared is 9. So we can say f of -2 is going to be 27. So that's how we would use the function notation to evaluate one part of the domain, -2. We can evaluate 6, or we can evaluate 0, whatever we want to. And that's how we evaluate functions.